Broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Depending on where you're logging in from, one of those will sound just about right. Welcome back to another great episode of our Best Practices webinar series with SevenSignal. I see a lot of you have joined early today, so if you would like to, please let us know where you're logging in from. If you are working from home, if you're in the office, I myself am working from our office in Cleveland, and I am joined today by Eric Camuli. How are you today, Eric?
I'm doing wonderfully, and I myself am working from home.
Awesome. Thank you, Eric. And we're both in Cleveland, as I said, where it is just starting to snow outside. So looking forward to the rest of the day with that, staying warm inside. I see a lot of you dropping in here. I see Abu joining us from South Africa. Thank you for joining us today. I see Todd working from home in Bloomington. I see Ronald joining us from St. Louis, also working from home. And Peter joining us again from Boston. Thank you to everyone for dropping those in there. If you'd like to, please continue doing so. And in the meantime, we will go ahead and get started here. So we are SevenSignal, the leader in wireless experience monitoring, and we'll go a little bit more into depth as to what that entails and what our mission is as SevenSignal. So we have a great topic here today, back by popular demand. As I said, I'm joined by Eric Camuli, our head of customer success. I'm Kelsey Rizzuto, the marketing specialist here at SevenSignal, and we are going to dive into Wi-Fi fundamentals, basic elements, troubleshooting, and myths. So we will go ahead and get started here. A few announcements before I begin. Just bear with me here before we dive into the presentation. We do partner with CWNP for every single webinar. So if you are pursuing a certification and are interested in receiving CE credits, you are eligible for those by watching these. So drop us a message and we can easily send you over a PDF certificate. Also, we do send out a SevenSignal newsletter every other Wednesday. So if you would like to receive that and you aren't currently, we'll go ahead and drop a registration link here in the chat so you can go ahead and do so. And in those newsletters, we love to send out relevant content to our community of Wi-Fi engineers, in addition to trivia questions, survey questions, like this one to the right here. Moving forward, we also host a product tour every single Friday at 12 noon Eastern. We'll go ahead and drop that link in the chat here as well if you would like to register. We additionally post all of our slides from each presentation to our Twitter account. So go ahead and give us a follow at SevenSignal. But if you don't have a Twitter account, you aren't active on there, no problem. You all will receive a follow-up email with today's presentation slides as well. Additionally, we post the recording from each presentation to our YouTube channel. For all of our archived webinars, you can also access those there. And if you're able to, subscribe to our YouTube channel, because coming up soon, we will be giving away some SevenSignal merch for YouTube subscribers. Really exciting announcement here. We are hosting our first virtual user group of 2021 on Wednesday, February 17th from 10:30 a.m. to 1 p.m. Eastern. This is a great way for us to link up industry experts, peers, customers, where we can all discuss how to elevate your organization's Wi-Fi initiatives. We'll also dive into the SevenSignal product roadmap, and we'll go into a recent IDC report and hear from an ROI analyst. This is a great way, as I said, to link our Wi-Fi engineers, but also we'll be diving into some of the ROI, the finance aspects of this. So share with your team, share with your colleagues, and we will drop this registration link in here as well. As I mentioned previously, we have been featured in a recent IDC report, white paper, the business value of SevenSignal for optimizing enterprise wireless connectivity. And we'll go ahead and give you direct access as a thank you for joining us today in the chat as well. All right, moving forward here before we begin, just a history on SevenSignal. We were established in 2007 in Helsinki, Finland, and we're now located in Cleveland, Ohio. We've hit a lot of major milestones along the way, as you can see here, such as the 1 billion data points that we're analyzing daily, in addition to the 5 million devices that we're monitoring daily as well. We also have 14 patents, which goes to show that the technology you see from us at SevenSignal, you're only going to see from us at SevenSignal. Just to give you a little bit more background as to what makes us so different, if you look at your typical enterprise LAN infrastructure here on the right, you've got great tools, great technologies already installed on the network that are giving you really useful feedback and useful data, such as your Riverbed, Cisco, Aruba, AppNeta, and more. But what we do is we pick up where they leave off, moving into a different space by living on the edge of the network with our product of Mobileye, which gives you full visibility into the user experience from the outside in. Additionally, Mobileye can be installed on ultimately any mobile device, from your laptops, your mobile phones, your Zebra scanners, your workstation on wheels, etc. And it can be installed on any Mac OS, Linux, Android, or Windows device as well. Additionally, we also have Sapphire Eye, which are the software-enabled hardware sensors for service level quality and RF visibility. And through this combination of Mobileye and Sapphire Eye, you're really getting full perspective, full visibility as to what's occurring in your network that you just can't find anywhere else. Additionally, a lot of us here on the line are working from home today, such as Eric here. And that enterprise LAN infrastructure isn't as helpful and relevant anymore when we're working remotely. So with Mobileye, we can also give you visibility into the external home networks, whether you're working from your house with other users on the network, whether you're working from a multi-tenant apartment, we can give you that perspective and that insight as well. All right, thanks for letting me run through those points before we dive into the presentation. But before doing so, we are going to launch a trivia question here that Eric graciously provided us. All right, Eric, can you see this question?
I sure can.
All right, what's the best way to improve Wi-Fi coverage for your home? So I see you all.
Well, that is a great question. Yeah, and you know, it certainly is up for debate. You know, people will have their opinions, and some people might even be a little misled and not sure. So hopefully by the end of today, we'll have really straightened it out for our audience. So Kelsey, what's the tabulation look like?
All right, we are going to close this poll now. Okay, Eric, how did we do today?
Well, you know what? I am pleasantly surprised. And that's because half of our audience chose the answer as the best way to improve your Wi-Fi coverage to move closer, or to move your home router towards the center of your home. That is a simple, inexpensive, therefore, in my opinion, best way to improve Wi-Fi coverage in your home. You don't have to buy anything, you know, like buying a mesh system or an extender, and we'll talk about those a little bit today. Sometimes you can't get closer to your home router because of just, you know, such, but if there is the ability, you know, for instance, in my house, when I got rid of my cable box downstairs attached to my television, I said, you know what, here's a perfect opportunity for me to plug in my modem in that spot because it's centrally located in my house. And I'll tell you, that really did the trick. So good job, everybody.
Yes, great job, everyone, and thanks for dropping in those answers. We are going to go ahead and switch controls here to our head of customer success, Eric Camuli, and Eric will start diving into today's presentation.
Okay, awesome. So let's make sure that we can see the correct screen. I'm going to show this screen right here, and let me know if you can see my title slide, Kelsey.
Yes, I can.
Okay, then let's get moving. So what we try to do here at SevenSignal when we have these Wi-Fi fundamental type webinars is we try to keep it simple. We try to use language that anybody can understand. And I know that there's folks out there who have varying degrees of knowledge when it comes to Wi-Fi. You might be a beginner, intermediate, or advanced. So even if you're an intermediate or advanced, what we try to do is use language and try to keep what we teach here today very practical so that anybody can apply some of the knowledge that is here today. So I look forward to sharing this with you guys today, and let's get into it. Guys, at the most fundamental level, when we talk about Wi-Fi, we're talking about radio, okay? Wi-Fi is radio. So just like when you tune in to your favorite radio station, I know Kelsey likes, 97.5, classic rock. And, when you tune into that, you're listening to those electromagnetic pulses coming over the airwaves down to a radio. It's really the same concept, okay? Now, just like what we know, about radio, there are certain properties, and those are the properties that we're going to talk about today. All right. Now, the first thing that we're going to talk about is basically licensed versus unlicensed spectrum in the air. So just like when you tune into the radio and you tune into 97.5 FM classic rock, they are the only outfit here in our local market that is allowed to broadcast over that frequency. If somebody else tries to broadcast over that frequency, they get in trouble with the FCC. That is a licensed frequency. And most frequencies out there are licensed, where you've got to pay money in order to broadcast your signal over that frequency. However, there are also unlicensed frequencies out there. And this is where Wi-Fi resides, on these unlicensed frequencies, meaning that they are free for anybody out there to use. Now, because they're free, sometimes that can cause problems, okay? And this is actually what we're going to talk about today. We're going to talk about these problems. So the two bands of spectrum that are free, the areas where Wi-Fi is allowed to operate, we refer to them as the 2.4 gigahertz band and the 5 gigahertz band. And think of these as like two highways. And these two highways that run through town, they have different properties, they have different elements, and we're going to talk about that next. Remember a moment ago, I said, oh my gosh, these airwaves, and there's licensed, they have sliced and diced the airwaves into a million little pieces, like what you can see on the screen. And the arrows are pointing to where 2.4 and 5 gigahertz reside. Okay, so right over here, this is your 2.4, and on this FCC chart, it kind of shows up as amateur radio. And then here's your 5 gigahertz over here, shows up as amateur. But look at this, guys. It is sliced and diced into a million pieces in order to ensure that only certain people are broadcasting over certain frequencies in order to get a specific job done. Okay, and people pay a lot of money to the government in order to have the right to do this, to broadcast their signal. Like, for instance, AT&T or Verizon, they pay big bucks in order to reserve whole bands of spectrum so that they can actually use it for their customers. All right. These are the big four topics that we're going to talk about today. If you're going to understand Wi-Fi and how it works and the fundamentals, remember, we like to keep things practical here, then you've got to understand congestion, propagation, interference, and also how devices play a big role in all of this. So we're going to jump right in with our first topic, which is congestion. And when it comes to congestion, guys, think about the highway. All right, remember, you've got the highway, and on the highway, you've got lanes. In Wi-Fi, we call those lanes channels. All right, and just like with Wi-Fi and just like on the road, when all of those lanes fill up with cars, things start to slow down. Same principle in Wi-Fi, guys. In most Wi-Fi environments, almost all, Wi-Fi clients will operate with or interact with the router or access point just one at a time. It's similar to getting behind a car on the highway. And if that car is going slow, well, you got to wait. You got to wait for them to get out of your lane. You got to wait for them to turn before you can go fast. The way that clients are interacting with the access point or the router is simply one at a time, okay? Regardless of what you've heard about technologies like MU-MIMO and OFDMA. This is the way it operates for most folks today, okay? Now, what you're seeing on the screen here is really something very interesting because you've got this whole lane right here, which isn't busy at all. This is the diamond lane or the high occupancy, the carpool lane, and it's completely empty. This is a perfect example of poor planning. All of these cars, all of these clients here are shoved into these 2 lanes, squeezed in, but if they had the ability to spread out, then everybody would be able to go faster. And this is a really important principle for you guys to understand in Wi-Fi, is that the more lanes, the more that we can spread out, the faster that we can go. And with that said, we head right to our next slide. Remember, I said these 2 different highways, they have different properties. The 2.4 gigahertz highway is really just like a 3-lane highway. That's it, a 3-lane highway. We operate on channel 1, 6, and 11. Okay, and these channels, this is a 20 megahertz wide channel here. Okay, and you can see this, it's not to scale, but down here you can see the same thing. Now, a lot of people, they say to themselves, well, you know what, Eric, what about channel 1, 2, 3, and 4, and 5? Those are out there, and we see this everywhere we go, where we'll look and, you know, somebody out there is like, oh, well, if you're on channel 1, then I'm going to be on channel 2 and everything will be fine. You're not going to be fine, okay? Overlapping channels is bad in Wi-Fi. You do not want to be overlapping. Overlapping is going to cause collisions in the air. And those collisions are going to lead to retries. And too many retries are going to lead to a stepping down and a lowering and a slowing of data rates. All right, so you don't want to overlap. You need to stay in your lane, okay? And these 3 lanes are channels 1, 6, and 11, okay? And it has to be this wide in order to really, you know, why? Because that's your car is that wide, all right? It's not like you're driving a scooter, okay? Your car needs to operate in a lane, and your computer needs to operate on a channel, and that requires a 20 megahertz wide channel in order to fulfill, you know, what's required in the 802.11 protocol. So 1, 6, and 11, if you're not on 1, 6, and 11 and you're on a 2.4 gigahertz network, you're in trouble. Imagine this, guys, you're driving down the highway, you're in your lane, and then you see out of the corner of your eye, all of a sudden somebody starts to drift into your lane. Whoa, you got to tap on the brakes. Otherwise, you're going to have a collision. It's the same thing in Wi-Fi, guys. Stay in your lane. And in 2.4, it's 1, 6, and 11. Now, remember, I said anybody can use these highways, all right? And you know, and you gotta stay in your lane, and you can't drive on the median, and you can't drive on the shoulder. You got to stay in your lane. And these 3 lanes, they fill up fast, all right? They fill up fast. So that what we call very low capacity. These 3 lanes fill up, and you know. And this is why what we try to do is we try to steer clients to the 5 gigahertz highway where there is a ton more capacity. Look at this. It's like having a 20-lane highway. Depending upon where you are in the world, you could have up to 24 lanes at your disposal. Much more capacity. On 5 gigahertz, everybody should be able to spread out and go fast. But once again, it can be, you know, it could be crazy because not everybody is aware of what channel everybody is on, like in an apartment building, and it could be really problematic where like all of a sudden everybody is in the same lane on the highway when they don't even need to be. Guys, we see this all the time. Like for instance, in my area, we have Spectrum cable. Where you live, it might be Comcast, or maybe it's Xfinity, or it's AT&T, or wherever it is where you get your internet. And when they give home routers out to everybody in the building, they're all kind of pre-configured and they're all on the same channel, channel 36 or channel 149. Well, this is horrible, okay? They should all be on different channels so that everybody can drive in different lanes on the highway. When they're all on the same channel, that's the equivalent of bringing out the orange barrels and making everybody squeeze into one lane on the highway. And that's going to cause congestion. And everybody's going to slow down to a grinding halt, all right? Bad. So you need to be able to know how to check your channel. And then of course, you know, with SevenSignal Mobile Eye on your device, you can see what channel everybody else is on around you also, which is really nice. Now there are some other cool things that you can do on 5 gigahertz that are sometimes recommended. And one of these technologies is where you can bond 2 channels together. We call it channel bonding. And so you can see over here where we bonded 2 channels together to create something called HT40, high throughput, 40 megahertz wide channel. And over here, we combined 4 channels to make something called VHT80, very high throughput, 80 megahertz wide channel. I know, it's pretty fancy names. Now this is fine. This is basically giving you the ability, this is like creating a super lane on the highway for cars to go super fast. You literally are enabling the ability, or you're enabling somebody to go twice as fast when you double the channel width like this. Now you say to yourself, wow, you know, I'm going to bond the channel so I can go twice as fast. But guys, you've got to remember, okay, you could be driving down the road in like your little, you know, beat up little car. You know, you got some beat up Chevy pickup truck from, you know, 1970 going down the road. It's not capable of going fast. So sometimes bonding a channel together like this is just not a good idea, because you don't have a really fast sports car that can even take advantage of that super lane on the highway. So what you see is that the cable companies, they, you know, pre-configure these routers, or people think that they can go twice as fast or even 4 times as fast by doing all of this bonding. But when you bond like this, you're now cutting down on the total number of available channels. And in doing so, also run the risk of causing interference with cars that are in the neighboring channels. Okay, you can cause overlapping. And remember what we just said a minute ago, overlapping is bad. I mean, what if right here you've got somebody on this channel in your next door neighbor, and then in the apartment below you, you've got somebody on the next channel right here, and then you're trying to do this bonding right here. All 3 of you are kind of colliding with one another, and that is a problem. Okay, that is a problem. So when it comes to congestion, you've got to be able to see who's, just like when you're driving down the road, who's in this lane, who's in that lane, and then you can kind of pick your lane so that you can go fast. All right, so this is pretty cool. This is a nice visual of what's coming, what we have today, and also what's coming down the pike. Okay, so up here you can see at the top 2.4, very little capacity, and then 5 gigahertz. Wow, look at that, tons of capacity. Now guys, this is pretty exciting news. The FCC just made an announcement recently that they are going to be opening up a whole new highway, and that's the 6 gigahertz highway down here. You see that? Look at all of this capacity. It's almost double the capacity of 5 gigahertz. Look at that. Where 5 gigahertz had 25 non-overlapping 20 megahertz wide channels, look at this. 6 gigahertz, 59 20 megahertz wide non-overlapping channels. It's crazy awesome. Okay, now this is called Wi-Fi 6E, not to be confused with Wi-Fi 6. So you're hearing about Wi-Fi 6 everywhere now, right? That is a protocol. Wi-Fi 6 is the new nomenclature that we're using to describe 802.11ax, which is the standard, the protocol. This is a frequency, okay? And in order to talk to this frequency band, you've got to have that radio in your laptop computer. If you don't have a 6 gigahertz radio in your laptop, then you're not going to be able to talk to a router or access point that has a 6 gigahertz radio in it. In my opinion, this is still about a year off, okay, before consumer devices. Now, you're already starting to see some manufacturers make access points and routers with 6 gigahertz radios in them. But I would say it's probably going to be, I don't know, maybe a year or so before you start to see client devices that have a 6 gigahertz radio in them, okay? But when it does come down the pike in the next year or so, it's going to be rather exciting. Look at how you can spread out. Everybody should be able to go really fast. And look at the bonding capabilities. Look at that. 29 non-overlapping 40 megahertz wide channels, okay? Wi-Fi 6E. All right, next topic. Let's talk about propagation. All right, so high frequencies and low frequencies, they have different physical properties. Okay, and so these lower frequencies, you can kind of see on top, lower frequencies, they've got kind of a different pattern, and they can travel over much farther distances as opposed to the higher frequencies. Okay, so like for instance, when I was a kid, I would tune in my radio, and sometimes I can pick up some AM station on the other side of the world. Remember that? Okay, it's the same thing. Those low frequencies, they can go really far traveling, and they can propagate really far. Higher frequencies, they peter out a little bit more quickly. They have a harder time getting through surfaces. Okay, as you can see here, it's more of a milliwave. So low frequency, 2.4, that is a lower frequency than 5 gigahertz, which is a higher frequency. And then when we get into 6 gigahertz, that's an even higher frequency. And as a result, you're going to run into maybe some propagation issues there as well. So in practicality, imagine that this is your house. And in your house, you probably have a router that's dual band. Dual band. That means that you've got one radio in it that can switch back and forth between 2.4 and 5, 2.4 and 5, and it's serving different clients accordingly. Now, maybe you've got a more expensive router in your house that has one of each. Okay, it has a 5 gigahertz radio that's dedicated, and it has a 2.4 that's dedicated. And this is how it works. Remember, the signal only propagates so far on 5 gigahertz. So this person right here in the middle of your screen, they're going to be able to take advantage of that big highway with all those lanes so that they can spread out and go fast. Okay, so here, the kids out here in their rooms, they are relegated to the slower 2.4 gigahertz network that is much more congested. And then this person right here, okay, this person right here, what are they gonna choose? Well, they actually can't choose. It's not their choice. Their device is going to make the choice. Their device has a wireless LAN adapter in it and drivers that govern that adapter. That software is going to evaluate the situation and make a choice to either join the 2.4 network or the 5 gigahertz network in your house. And sometimes it makes the wrong choice, and that could be problematic. And if it makes the wrong choice, and maybe you're on the 2.4 network, then you have to share with your kids who are doing Zoom school and who are playing games and who are doing who knows what else, watching Netflix, watching YouTube videos. In order to get onto the 5 gigahertz network or radio, you may need to move a little bit closer, okay? Now, if I wanted 5 gigahertz out here in this no man's land, or to reach all the way, okay, one thing that I can do is I can create like a mesh network. All right, and we see these mesh networks popping up all over the place. They're like these little probes that you put around your house, right? And so that's what you're seeing up here in the upper right-hand corner. These little probes, you put them around the house, and then you're basically giving yourself the ability to roam from one probe to the next probe to the next probe and give your entire house this blanket coverage. But there's one thing that I want to warn you about with those, okay? There are some out there, and I think the Google one is like this, the Google Home, whatever it's called, where all 3 of the probes, they put them all on the same channel, like channel 149. And in my opinion, that's a bad idea, all right? Others, one of the probes will have like an uplink channel where one of the probes is on channel 36 and then the other probes are on channel 149. And I like that because that's like having 2 lanes on the highway where people can spread out, okay? As opposed to 1 lane on the highway, trying to jam all of your traffic into 1 lane on the highway where everybody's on channel 149. All right, so I'm not a fan of that. If you get one of these mesh networks, you might want to do a little bit of research to find out if you have the ability to actually set what the channel is for the one that's going out to the internet versus the other ones that are inside the house. Okay, so be careful, be careful. Other than what I just mentioned, these are some pretty cool systems. By the same token, they can be a little pricey. They can be a little expensive. Now over here, guys, in the lower left-hand corner, this probably looks familiar to you. This is like your Wi-Fi extender, right? And everybody thinks they can go out and get an extender and that's going to solve their problems. And it might, okay? However, I'm not a fan of extenders because extenders are what I call half-plex and not full duplex. And what that means is that when the signal goes from your home router to the extender, from the extender to your computer, and then from your computer back to the extender, from the extender back to your router, it's basically cutting your throughput in half. Okay, it's cutting your throughput in half. Depending upon your application, what you're trying to do, that could be a problem for you. All right, if you're trying to do voice calls, not recommended that you're on the extender. If you're just doing some simple web browsing, not a big deal, go to the extender. But please be aware of how these things work so that you know. And this was our trivia question today. You know, how can you increase coverage? I mean, you could get an extender. Like I said, not a fan. You could get a mesh network. I like this idea of putting a router in the middle of your house, and then that gives everybody in the house the best opportunity to get the best signal. So that's signal and coverage. A little bit more on this topic. You know, why does my radio cut out when I drive under a bridge? That's a great question. And it's because of barriers to propagation. And the two surfaces that we are most concerned about when it comes to Wi-Fi are metal and concrete. Okay, when it comes to concrete, the radio waves are just, they're not going to go through the concrete. They're going to be absorbed into the concrete, and then that's it. You're done, you know? So, you know, you got to drive, you know, the radio cuts out, and then when you're out from underneath the bridge, the radio comes back so that you can get the signal again. And then the other is metal. With metal, you're going to have reflections. The radio waves are going to reflect. And so depending upon where you live and your environment, this could be good or it could be bad. For example, with concrete, let me give you an example of where this is good. This is good if the walls in your apartment building are all concrete, because basically it's insulating you from all of the signals around you. All right. And so, you know, there's going to be less interference for you as you work with your Wi-Fi. So that's good. Now here's a bad example. So I'm thinking about my dad in Florida. He called me up, and he lives in Florida, and all of the walls of his home, including the interior walls, are all concrete block. And he called me up and said, Eric, I don't understand, you know, with Wi-Fi in my house, my router is literally in the next room over. Why can't I get good Wi-Fi? I'm like, well, Dad, that on the other side of that wall, that's a concrete wall. And so your Wi-Fi signal is, you know, just can't, you know, sneak around the wall and get to you. It's trying to go through that wall with its, you know, omnidirectional antenna. It's trying to poke a hole through that wall, and it just can't do it. You're going to need to move that home router to some place where you can get better line of sight. Okay. Or you're going to want to go to that mesh network where you can put these little probes around your house so that no matter where you are, you've always got line of sight, if you will, to one of these probes that you can connect to. And that is propagation. All right, now we're going to talk about interference and noise. Remember, this is radio, guys. And so even though you and I can't hear it, it's out there, it's noise. All right, and so just imagine you're listening to your favorite radio station and you're jamming, and then somebody else comes along and they start blasting their tunes, and somebody else comes along. What happens? You can't hear your favorite song anymore. It's the same concept in Wi-Fi. When all of these signals are in the air, they're all, you know, clamoring over one another, and it's just a big, muddy, jumbled mess. And now your client device can't hear your radio, and your radio can't hear your client device because it's competing with all of this noise. And in Wi-Fi, what happens in order to deal with this, okay, high, fast Wi-Fi, okay, is very sensitive to noise. And what winds up happening is when this is detected, your Wi-Fi radio and your client, in order to try to cut through the noise, will negotiate a lower, slower data rate. So your Wi-Fi is just going to get slower and slower and slower. This is equivalent to, okay, I'm going to drive up a really steep hill. You're not going to do that in fifth gear. There's just no way. You're going to have to downshift to like first gear or second gear in order to get up that steep hill, in order to overcome the gravity. Well, in this case, in order to overcome the noise. And that brings us to our next topic. This is probably something that you've heard before, this idea of signal to noise ratio. One of the temptations is, okay, if I have the ability to do so, and usually you can't on a home router, but can I turn up the volume on my radio? Can I boost the signal in order to overcome the noise? All right, and that's what we call signal to noise ratio. So I basically am shouting over everybody else so that I can hear better and I can have a better experience. Well, the problem with this is that now you're causing problems for your neighbors, and so it's not a nice thing to do. All right, so now this neighbor and this neighbor, I mean, what if they turned up their volume? And in some environments, this happens automatically, and then you're right back where you started in terms of a big, loud, jumbled mess, okay? One of the biggest interferers of Wi-Fi is other Wi-Fi, okay? These signals are all around you. You can't see them. You can't hear them, but they're out there, and they're competing. What you want to do in order to overcome this situation, okay, is you want to move someplace quiet. All right, this is like 2.4. This is like the 2.4 network. You want to go to 5 gigahertz where it's nice and quiet, where everybody can spread out, and everybody should be able to go a lot faster because there's a lot less noise, and I can hear loud and clear. Okay, and we use technology in the enterprise like band steering technology in order to steer clients from 2.4 to 5. Now, remember what I said a moment ago when I said it's actually the client that's going to decide whether to choose 2.4 and 5. That is still the case. Band steering technology attempts to influence. It attempts to influence clients by either slowing down the beaconing or advertising of the 2.4 network or speeding up the advertising of the 5 gigahertz network so that when your client device comes along, it picks up on the 5 gigahertz network first and decides to join it very quickly. Okay, so that's sort of how band steering works. It's not, you know, I just can't go to a client and say, hey, yo, you, I want you on this network right now. No, it doesn't work that way. Your device makes the decision. Okay, now here's how we compare the spectrums. Okay, on 2.4, it's like walking into a crowded, noisy sports bar, watching your favorite team, and hopefully, you know, we'll be able to do this again one day, but it's really hard to hear. You know, you gotta, you know, you're saying, hey, what did you say? Over and over again, as opposed to 5 gigahertz where it's nice and quiet and everybody should be able to have a wonderful time just speaking nicely to one another. It's great. All right, so that is noise. This is what it looks like in SevenSignal. Okay, so this is the 2.4 gigahertz network, and here's channels 1, 6, and 11. Look at this. So everybody is staying in their lane just fine. Each one of these arcs is another network, and everybody is staying in their lane just fine. No overlapping, but look how many cars are in these lanes. Oh my gosh, so this is going to be really slow. This is what we call co-channel interference. Co-channel interference, look at how many cars, how many networks are all competing for this air in this lane. And so that's going to be slow. Over here, we don't have as many cars on the highway, but look, they're not following the rules. They're all overlapping and weaving in and out of traffic. I mean, this is a nightmare. I mean, overlapping channels, I mean, this can be even more destructive, in my opinion, than co-channel interference. And we call this adjacent channel interference, this overlapping. I mean, if this is a busy network right here, and this is a busy network, when these packets are transmitted, these frames are going to collide in the air, and it's going to lead to a retransmission. Okay, and if these networks are busy all day long, I mean, it's just going to get slower and slower and slower, and it's going to be very frustrating. Instead, this is what you want your 2.4 to look like over here on the right. Not a lot of cars on the highway. Everybody's in their lane. You see that? Very nice, very nice. Now, if you have the ability to get off of 2.4 and onto the faster highway, then I encourage you to do so. Get onto 5 gigahertz. And that's why, you know, a nice practice is in your home, you can configure your router to 2.4 and 5, and you should give them different names. So this is like home network 2.4, home network 5. That way you always know what you're on. And if your computer made a bad decision, you can then just fix it by selecting the other one and getting onto the better network. And sometimes when they're named the same, you don't know what you're on, okay? And that could be frustrating. We even have these problems on 5 gigahertz though. Remember what I said with, a lot of people, they just make 80 megahertz wide channels, they make 40 megahertz wide channels, and they start overlapping with people who are just using 20 megahertz wide channels like right here. This is a problem. This is becoming a big, big problem. Okay, this is more of what you want over here, everybody spreading out. But if you don't know what's going on in the air around you because you don't use SevenSignal or something like that, then your Wi-Fi could be slow and you have no idea why. And it's because you're competing with these other networks and they are interfering with you. These are other cars on the highway that are basically like slamming into your fenders, okay? And that's going to cause you to tap your brakes. It's going to cause you to have a poor experience. Okay. This is a feature that we call radio resource management. Radio resource management is a feature that's on a lot of enterprise systems, and what it tries to do is change channels and adjust power in order to avoid interference. This is a pretty cool animation. I'm proud of myself for this. And you know what? Most of the time it works pretty well. Sometimes it doesn't. And sometimes it runs into this problem right here where all adjacent access points are on the same channel. Again, this is just like you've got a 3-lane highway, and then all of a sudden here come the orange barrels. And now you're making everybody squeeze into 1 lane on the highway. And that 1 lane is channel 36. Going to be a bad experience. All right, this is the final topic. We're going to talk about devices and how your devices make a big difference in your Wi-Fi experience. So the way to illustrate this is we use this little game we call Which Would You Buy? And you've got these 2 computers, and they both look about the same in terms of configuration. But one of them has a faster processor. You see this one over here on the right? It has an i5, and you say to yourself, ooh, that one's better. That one's faster. I'm going to get that one. Unfortunately, if you would have chosen this one, you would have chosen poorly. And the reason why is because you would have chosen a laptop with a BGN adapter, which is not even capable of getting on to a 5 gigahertz network. Not even capable. What you need to look for, guys, in the fine print is the letter A. The letter A in the 802.11 protocol is the amendment to the standard which supports 5 gigahertz. So over here, if this said A BGN, you'd be fine. If it said AGN, you'd be fine. But with no A, you are relegated to the slower, more congested, more crowded 2.4 network. Okay, so you could buy this brand new computer and give it to your kid, and you think that you got a great deal, and then they do Zoom school and they're having a miserable experience. And you're like, oh my gosh, what happened? And you don't know what the problem is. This could be the problem. All right, you better know your Wi-Fi standard. So over here, you've got AC, looks good. If it said AX, no problem, letter A. Now, in order to help out with this alphabet soup, the Wi-Fi Alliance came up with a new nomenclature. And so now they're using Wi-Fi 5 and 6 in order to help folks out. And the latest and greatest is Wi-Fi 6, which is 802.11ax. All right, so you should only be getting devices that are Wi-Fi 5 and Wi-Fi 6. Wi-Fi 5 is 802.11ac, and Wi-Fi 6, which is the newest, is 802.11ax. And these are the fastest. This is the most current or most recent protocol or standard that's available to devices today. Not to be confused with Wi-Fi 6E, which is a whole nother highway. It's a band of spectrum. Wi-Fi 6E is frequency. Wi-Fi 6 is the protocol. All right, so there you go, guys. This is it, home stretch. So, in order to have a great Wi-Fi experience, you really have to be paying attention to all of these different factors. It could be something in your environment. It could be that you've got noisy neighbors and their Wi-Fi signals are interrupting yours. It could be that you've got concrete walls or metal shelving. It could be your device. It could be that your device isn't even capable of going fast, okay? It could be your ISP, all right, where you only pay for 20 megabits of throughput down and 1 megabit of throughput up. All right, so again, you're being throttled by your network, by your ISP based upon what you paid for. And then finally, it really could be your home router. And that's what I mean when I say network over here. Your home router could be really old. You haven't swapped it out in about 6 or 7 years. And, it's not capable of going fast either. So all of these things have to work in conjunction together in order to have a great Wi-Fi experience. All right. So hopefully we gave you some good tips today. All right. Here we go. If you have problems with roaming, your device is maybe stuck to the base station upstairs when you want to be attached to the base station downstairs, you need to upgrade your adapter and drivers. If you're having coverage issues, you need to get closer, or you need to move your router to the center of your home. Congestion, try to get out of that congested lane. If you got slow cars in front of you, try to get into another lane on the highway, another channel, if you will, on your router. Switch channels. And again, along those same lines, if you have noisy neighbors and there's a lot of interference, you want to switch channels by going to someplace quiet. All right, so there you have it. Kelsey, I'm going to hand it back over to you. Hopefully there's maybe a question or two out there that we've got time for. And I just want to thank everybody for tuning in and learning more about our topic.
Yes, thank you, Eric. Great presentation. I encourage all of you, if you do have a question, drop it in the questions panel and we'll see how many questions we have time for today. Maybe one or two, but I will go ahead and kick it off with this first one. Jean would like to know what wireless propagation issues should be expected from fog and rain in an outdoor environment?
Well, the easy answer is that you should expect some propagation issues. Basically, and I don't know about fog so much as rain, but hard rain, that is going to cause a propagation issue. Water is kind of what we would call a medium barrier to propagation. Not terrible, but a medium barrier to propagation. So if you have an outdoor access point and it's raining outside, then it is going to cause some potential issues. So you just need to be aware of it. You don't know until you're actually in the situation. Obviously, there's hard rain, there's soft rain, but I would certainly expect some barrier to propagation to interfere with the experience that you're trying to have.
Awesome. Thank you, Eric. And I believe that is the only question that we have time for today. If you do have any other questions, we can surely respond to those via email. But I would like to take the time just to thank you, Eric, again for a great presentation. Always a pleasure to have you on here. And thank you to all of you for joining us today, for giving us 45 minutes out of your workday to dive into this. So have a great rest of your day, and we hope to see you all at next week's webinar. Thanks, Eric.
Thank you, Kelsey. Thank you.
Thanks, everyone. Have a good day.